Hi everyone. The rest of what I want to work on in 2.4 is just rewriting some scarier, messier looking things. So back to our theme, see the simpler problem hidden in the mess. So here our directions are rewrite as a product, which might sound a little different, but I really want you to think of it that way. What that really means is factor, and I've said that on your worksheet so that you're not confused. But that's what we do when we factor. We take a sum or difference and we rewrite it as a product. So our tricks for factoring are factor out a greatest common factor, look for a special form, which would be like a difference of squares for us is the big one. And then, okay, let me think about how I want to say this. So always look for a greatest common factor. If you have two terms, you want to think about if there is no greatest common factor, is it a difference of squares? If you have three terms, you want to think about, can I do my factor trinomials business where I try to unfoil it? And if you have more terms, then again, always GCF first, maybe look for one of your special forms or maybe look for a factor by grouping. Okay, so here, greatest common factor. So this is a little weird with the negative powers, and if you'd like, you can rewrite those as fractions first or last or never. I'm actually fine with for this problem. I really do just want to throw some kind of different looking things and see if you can do some form of factoring. So if you try something a little different and you want to know if I'm okay with it, just ask. I probably am. That's one of the reasons there's a lot of worksheet stuff here as opposed to just online stuff so that you'll get credit even if you do a little bit different thing. So what I'm thinking is, here, you know what, I think I am going to actually rewrite as fractions because it feels pretty weird to me to factor out negative powers, although it is doable. 5 to the 2x, sorry for my weird 5 to the x. So I'm going to say, okay, I have 5 to the 2x over x squared minus 5 to the x over x. So if I want to rewrite as a product, I'm trying to find something that I can factor out. You can factor out things that make it not nice, but I'm still trying to factor out things that keep it nice. So I can see that both of them have an x in the denominator. One has an x squared, but I'm just going to take the x so I don't make any weirder fractions. I'm going to factor out a 1 over x, and then in the top, you had some of these weird factors earlier, and I don't know if they stuck or not. Remember that a 5 to the 2x is the same as 5 to the x times 5 to the x, so I should be able to factor out a 5 to the x. So if I remove a 5 to the x from the first one, there should be 1 left. And if I remove an x, 1 over x from the first one, there should just be a 1 over x left. So I've got 5 to the x over x. And then I removed all of the second one, so that would just be minus 1. And again, I know this looks a little weird. Your best way to start making sense of this is just to try something out and then multiply it into check, right? So your check here would be, if I multiply 5 to the x times 5 to the x, I add powers, 5 to the x plus x, and then the bottom, I multiply x by x, that's x squared, and then 1 times 5 to the x over x is just going to be 5 to the x over x. So notice that x plus x does turn into 5 to the 2x, and everything else looks great. So that really is a factored form. So I still think if you've got negative exponents, probably your easiest bet is to go ahead and do that. Another thing you could do, though, is to say, okay, well, I see that I have an x to the negative 1, and this is the same as an x to the negative 1 squared. So you could look at it that way as well and factor out an x to the negative 1. So lots of options, but there's one way to deal with it. Okay, let's look at the next one. So lots of tricky looking factoring. So that one was all greatest common factor. Let me go back really quick. And what I ended up with, I don't think I'm going to get any further. I don't see difference of squares, and it's not a trinomial, so I'm good. This one, I do think I have a common factor. So I wouldn't rewrite this as roots if my goal is to factor it out. I think it's easier to think about if you have the fractional exponents. So I can take out the biggest power of t I have is t to the 1/2. They all have t's in them, so I'm going to take out a t to the 1/2. I don't see that I can take out any constant. My coefficients are 2, 1, and 3, so I don't see anything to take out there. Remember that when you take out t to the 1/2, it's like you're dividing it out. So we're going to be subtracting 1/2 from all of our powers. This is a really nice trick sometimes. Just a fantastic one that people don't always think of. So we can separate that out, and it knocks all of our powers down by half. So 5/2 minus 1/2 is 4/2, which is a nice even t squared. 3/2 minus 1/2 is 2/2, which is a nice even t. And 1/2 minus 1/2 gives us t to the 0, which is just 1. Again, if you aren't fully sure, distribute and make sure you get back where you started. I think I can actually do a little better. I factored out that t to the 1/2. I think I can split up the trinomial. So I'm going to say I have a 2t and a t. And if I get a 3 and a 1, I think I want to do them this way so that my outside is 2t, my inside is 3t. And I can make it a -3 positive 2 to get my -t in the middle. So there it is, fully factored. So sometimes when there's a lot of radicals in the mix, factoring out a square root, or if you have a fraction, multiplying top and bottom by a square root, can all of a sudden make them all really nice and easy. Okay, I just want to do one more on the factoring. You have kind of a whole variety, but I think this should give you an idea of what to look for. This one looks really, really bad. But again, I think I do have greatest common factor that can get me started. So I would say number one here is to recognize that what we have here is a bunch of multiplication and then this addition in the middle and a bunch of multiplication. So this is the big operation. We would work in the roots and the powers. We would do a bunch of multiply. The last thing we would do would be add. So this really is written as a sum. And within that sum, I have term number 1 and I have term number 2. And I'm hoping to spot in each of those common things that I can factor out. So looking for, let's just go through the first one, a w. Can I factor a w out? And I would say the answer is yes, because I have lonely w sitting there as well. I can take one of the 3. The next chunk is w minus 4s. I have 5 of them in the first term, and I have 4 of them in the second term. So I should be able to take out 4 of them. I'm going to go ahead and keep track. I think I can take 1 w. I think I can take 4 w minus 4s. And then the last chunk I have is this root 3w plus 2. And that entire thing appears in both of them. So I'm going to take that out as well. And then it's just a question of what's left over. So I took the w, it's gone completely. I took 4 of the w minus 4s, but that does leave me 1. And then I took the root 3w plus 2 completely as well. So from that whole first mass, this whole first thing, all I have left is a w minus 4. It was a plus in the middle, so that's that same plus with an arrow over it at the top. From the next one, I didn't take the 3. This 3 right here is still there. I did take 1 of the w's, so now there's only 2 left. I took all of the w minus 4s, so that's gone. And I took all of the root 3 minus w, so that's gone. So now I'm going to go a little further and then I'm going to go talk about that mess at the beginning one more time, make sure people are thinking about how to spot those because they know it looks bad. Okay, so all that got factored out, and then in the parentheses, let me think about this. I had a 3w squared plus w minus 4. I think I can factor that. So I'm going to make it, I don't really need the brackets, but I'm going to keep them there just so you can see. I think I can do 3w and w and 4 and 1 so that I get 3w, 4w. And if I can make that a positive 3w and a negative 4w, I think I'm good. So that is looking fully factored. So they look really, really bad, but what I'm hoping, the simpler problem to see within this, let me erase some of my scribbling. Okay, the simpler problem in here is, here, we'll just leave the w's. So we have a w, let's temporarily call this thing x. So it's like we have w times x to the fifth, and I'm going to call this whole thing y times y plus 3w cubed. And here's our whole x again. So we have x to the fourth, and here is our y again. So that is still looks kind of messy, but that's the simpler problem. I have a single w in the first one, 3 in the second one. I have 5 x's in the first one, 4 in the second one, and I have a y in both. So what can I factor out? I can factor out a w, an x to the fourth, and a y. So that's the simpler problem hidden within all this crazy mess. Okay, thanks for watching the video on factoring.